Welcome to part 4 of the IAS Edexcel Chemistry Unit 2 Specification Revision. So, in our last video, we looked at the entirety of intermolecular forces. In this video, we will look at redox chemistry, okay? Maybe in the next video, we'll look at 8b, the elements of group 1 and group 2. Groups 1 and group 2, sorry. So, let's begin. 8.1. Know what is meant by the term oxidation number and understand the rules of assigning oxidation and numbers, okay? Oxidation numbers, sorry. So, the main thing about redox that we need to know is what is redox itself, okay? If we write redox, I don't know why I did that, but anyways, this first three letters and the last three letters, this one is going to be reduction, and the last two letters are going to be oxidation, okay? Now, oxidation is the loss of electrons, while reduction is the gain of electrons, okay? Gain of electrons. A way I like to, if you have like a confusion about these stuff, learn abbreviations that will help you understand these better, okay? So one is, a teacher once told me, oil rig. This is basically oxidation is loss, okay, while reduction is gain, okay? So oil rig is an important, it's a way to remember which one is gaining an electron and which one is losing an electron, okay? Because again, these might seem like very small things, but in the exam they can give you a 5-mark question about oxidation, and you think that it's reduction, so you might switch it up. So just memorize these stuff, okay? What is oxidation number? Oxidation number is this is a number that basically gives the oxidation state of an element or an ionic substance, okay? So it gives oxidation state. Again, no one will ask you for the definition of this, okay? So we just brush it up, giving general definitions about these stuff. But what you will be tested on, obviously not directly, but indirectly, is the rules for assigning oxidation numbers, okay? So an oxidation number of any element in the periodic table, so Cl or F or Ag, okay, they will all be equals to 0, okay? This is any element in the periodic table. Remember, it's just the element, okay? If it's in a compound, then it changes. If it's in an ionic substance, it changes, okay? So that just remember that. That's one. Secondly, oxidation number is neutral. So these all rules are listed very nicely in the physics and math tutor, but we'll just write them down here again. So oxidation numbers in a neutral compound add up to 0, okay? So let's say that we have a neutral compound like H2O. There's no charge here, there's no positive or negative, it's just H2O. So we will know that the charge here is 0, okay? So the total charge here is going to be 0. The third one, oxidation number in a charged compound adds up to the total charge, okay? What do we mean by this? If you have H3O plus, okay? This is when H2O gains a proton, so it becomes H3O plus, okay? The oxidation state for this whole compound is going to be positive 1, okay? Because of this. Hydrogen has an oxidation number of +1, while oxygen has -2, okay? Halogens all have -1 oxidation number, okay? Then we know that each of the groups, group 1, group 2, group 3, they will all have their respective oxidation numbers, okay? So +1, +2, +3, okay? And then, the behind the ending groups, like group 7, -1, group 6, -2, okay? Just remember those things, okay? Now, there are a few exceptions. We talked about oxygen having -2. This is not everywhere, okay? In peroxides, oxygen will have an oxidation number of -1, okay? Hydrogen has an oxidation number of +1 always, but there is an exception again. In metal hydrides, it will have an oxidation number of -1, okay? So these are a few, so these two are the exceptions, but everything else, it remains the same basically, okay? So that is the rules of the oxidation numbers, okay? Be able to calculate the oxidation number of elements and compounds. Okay, so again, for peroxides and for metal hydrides, it's written here, but let's just look at it really quickly. So if you've been given hydrogen and oxygen and you want to combine these two elements, you just write them down side by side. So H is going to be +1, oxygen is going to be -2, okay? What you do is you just cross these, okay? So now you get 2 here and you get 1 here. So you will have 2 hydrogens and 1 oxygen, that's H2O. This is the simplest way of doing it, okay? Like the simplest compound example that I could give you. But obviously it's going to get more and more complex as you use different compounds. But yeah, that's basically how you do it. And if you want to cross-check and see if it's correct, hydrogen, there are 2 of them, so 2 times +1, plus oxygen, this is 1 of it, so 1 times -2. You will get, this will be +2 plus -2, which is 0. Total charge of, it's here, sorry. Let me just draw that better. The total charge of a neutral, again, there's no charge up here, so it's neutral, is going to be 0, okay? Yeah, we can take that. Again, remember for peroxides and for metal hydrides, instead of using -2 for oxygen, use -1, and for metal hydrides, instead of using +1, you use -1 for hydrogen, okay? Yes, be able to indicate, so the next one, be able to indicate the oxidation number of an element in a compound or an ion using Roman numerals. Okay, what this basically means, so long ago, the Romans decided to create, a system. They will never ask you any of those stuff, so let's just go right into it, okay? Roman numerals can be used to give oxidation numbers. If you have a varied oxidation state, okay? So transition elements have varied oxidation states, right? So if you want to, like copper, for example, let's use copper as an example, it will have an oxidation state of +1 or +2, right? So what you can do is, so you have to specify when you're writing this stuff down, okay? Let's look at examples of these. Copper 2 sulfate. This is a common type of sulfate, okay? What is the presence or what is the value that this adds? This is essentially going to be the charge of copper, okay? Charge or the oxidation number of copper. So it suggests that copper has a oxidation number of +2, okay? Sulfate, again, they should be known, but if you do not know these, just go to Google and search up the, all the oxidation state of, compounds, and you'll see sulfates, you'll see all the other types like, hydroxides. Memorize all those things because that is very important, okay? They will throw 6-mark questions at you based on this stuff, so it's very important to know all those things. But again, with practice, you will memorize more and more and more, okay? Sulfate is going to be -2, so writing this down is just going to be CuSO4, okay? Simple as that. Let's say you have copper 1 sulfate. This changes now, okay? This suggests that copper has a charge of +1, so let's do our method again. +1, -2, switch it, you get 2 here, 1 here, so 2 coppers and SO4, okay? That's basically how that works, okay? Yeah, so that's about that. Be able to write formula given oxidation numbers, we have done that. Again, you will not always be given, like this given here, you will not always be given the oxidation numbers. So I suggest that you try and memorize as much as you possibly can, okay? Yeah. 8.5, understand oxidation and reduction in terms of electron transfer and changes in oxidation number. Okay, what we will look at is redox again, okay? This first part, reduction, like we talked about. This last part is oxidation, like we talked about, okay? Oil rig answers that first part of the specification in terms of electron transfer. Oxidation is loss of electrons, so minus electron. Reduction is gain of electron, okay? Let's try it here, reduction and oxidation, okay? Reduction is going to be loss of electrons, so a minus of electrons. sorry, oxidation is going to be a loss of electrons, so minus of electrons. Reduction is going to be a gain of electrons, okay? Now, in terms of oxidation number, what is oxidation and what is reduction? Reduction is a decrease in something, right? So if you have a decrease in oxidation number, that is going to be reduction, okay? If you have an increase in oxidation number, that is going to be oxidation, okay? These are the simplest terms of it, but yeah, that basically answers that question, okay? We can take that. Okay, next part. 8.6. Know that oxidizing agents gain electrons and reducing agents lose electrons. The definition is in the specification itself. So, but a way of remembering again, if oxidation is a loss of electrons and reduction is a gain of electrons, an oxidizing agent will cause oxidation, right? So it will cause something to lose electrons, right? That basically means that it will take electrons from a species in order to oxidize that species. So an oxidizing agent, so what we can tell about an oxidizing agent is that it will gain electrons, okay? So just remember that. And for reduction, so a reducing agent will do the opposite, right? It causes reduction, and if it causes reduction, it means that it's, a species is going to gain an electron. So a reducing agent will give that species an electron in order to reduce that species. So it will lose an electron, okay? That basically sums up that part of the specification. Next part, 8.7. Understand that disproportionation reaction, sorry, I have a hard time saying that word, involves an element in a single species being simultaneously oxidized and reduced. Okay, so what is a disproportionation reaction? It's a reaction in which the same species is oxidized and reduced simultaneously, okay? So let's look at an example. The most common example for this is chlorine being hydrated, okay? When you hydrate chlorine, you will get ClO minus plus a chloride ion, and you get two hydrogen ions, okay? So if we can see, we know our rules of oxidation numbers, right? An uncombined species, if a total species has a charge of zero, that means that the oxidation number here is going to be 0 for chlorine, okay? Here, ClO, so we can just write that here. We can see that the total charge is minus 1. So what we can write is Cl, there's 1 chlorine, so 1 times Cl, plus 1 times oxygen. We know that its charge is going to be minus 2, unless it's in a peroxide, then it'll be minus 1. But this is not a peroxide, so it's going to be minus 2. This is going to be equal to minus 1, this charge, okay? So Cl plus minus 2 is going to be minus 1. So Cl is going to be plus 1. Take this other side, it becomes plus 2. So Cl is going to be plus 1, okay? That's the oxidation number of chlorine in ClO minus. And over here, the oxidation number of chlorine is going to be minus 1. So we can see that Cl has gone from 0 in Cl2 over here, and it has gone to become plus 1 in ClO minus and minus 1 in Cl minus. We can see that there is an increase in oxidation number, so there is oxidation here, and there's also a reduction in oxidation number, so reduction happens here, right? So this is the simplest disproportionation reaction example, but that's basically what disproportionation means, okay? Yeah. Know that oxidation number is a useful concept in terms of classification of reactions as redox and as disproportionation, okay? We've just talked about all this. It's pretty much this entire example. The use of oxidation number will be able to tell us if a reaction is if a species is undergoing disproportionation or not, okay? So that's how oxidation numbers are useful over there. Understand that metals in general form positive ions by loss of electrons with an increase in oxidation number, whereas nonmetals in general form negative ions by gain of electrons with a decrease in oxidation number. That basically means that metals in general, so like metals like Al, sodium, aluminum, or sodium, and more metals will undergo oxidation in ionic compounds or just compounds in general. So it become Al3 plus, Na plus. So it shows that it has lost an electron, right? And non-metals like oxygen, or nitrogen, these will undergo reduction. They will gain electrons and they'll become O2 minus or N3 minus, So that's basically what it means. In general, non-metals will undergo reduction while metals will undergo oxidation, okay? We can take that. Be able to write ionic half equations and use them to construct full ionic equations, okay? Now this is a bit of an important topic, okay? Half equations will show the separate oxidation and reduction reactions in their own forms, okay? In a question in the exam, you'll be asked to write the half equation for reduction, or you'll be asked to write the half equation for oxidation, okay? So let's look at examples, okay? So if you have a manganate ion, MnO4 minus, plus SO2, sulfur dioxide, you'll get manganese 2 plus SO4 2 minus. This example is on physics and material as well, which we can see that here MnO4, so Mn 1 times, there's 1 Mn plus there's 4 oxygen. Again, this is not a peroxide, so minus 2 charge to give a total charge of minus 1. So this will be Mn plus negative 8 equals to minus 1. So take the minus to the other side, it becomes a positive 8. So Mn would have a charge of positive 7, okay? That is over here. Let's just rub everything now. Positive 7 here, Mn, okay? Over here, it has a charge of positive 2. We can tell by this, okay? SO2 so it has a total charge of 0. So there's 1 S, and there is, again, this is not a peroxide, so 2 times minus 2 is equal to 0. S plus minus 4 is equal to 0. Take the minus 4 to the other side, it becomes positive 4. Sulfur will have a positive 4 oxidation number. Over here, SO4 2 minus, same process. 4 times minus 2, not a peroxide, so minus 2 will be equals to negative 2. Negative 2 from here. This will be S plus minus 8 is equals to 2. Minus 2, is equals to minus 2. So sulfur will have an oxidation number of positive 6, okay? You can rub all this and write positive 6 here for sulfur. We can tell that Mn has decreased in oxidation number while sulfur has increased in oxidation number. This is not a disproportionation reaction because the same species is not being oxidized and reduced simultaneously. These are two individual species undergoing oxidation, one of it, and the other one is undergoing reduction. So this is a redox reaction, okay? When they ask you what type of reaction is this, don't say a neutralization reaction or any of the other reactions, okay? It is simply a redox reaction, okay? So write the half equation for oxidation and write the half equation for reduction, okay? Basically, manganese is being reduced while sulfur is being oxidized. So let's write the SO2 equation first. SO2, you write that on one side and you write SO4 2 minus on the other side. We know that oxidation is a loss of electrons, okay? And the oxidation number for sulfur has gone from plus 4 to plus 6. So this shows that if you have, let's look at it in detail because it's a very important thing, okay? Plus 4 means that there are 4 more protons than electrons, okay? Because protons has a charge of plus 1, electrons has a charge of negative 1. So let's just draw this, okay? You have, let's say you have 10 protons. 10 protons. Let me actually put positive charges, that's better. So you have 10 protons, okay? And you have how many electrons? Let's say you have 6 electrons. The total charge here is going to be plus 6 because there are 6 more protons than electrons. Now let's say you take out 2 electrons. Okay, you take out 2 electrons. Now there are 6 more protons than electrons, so it'll be a positive 6 charge. So 2 electrons has been lost, so they will be, so you can write plus 2 electrons here. So over here, 2 electrons, so you subtract, you can either write on, okay, so you can write it on this side as well. So minus 2 electrons, and we know that if we take this to the other side, it becomes positive 2 electrons, so we can just rub it. You can write it both ways. You can write minus 2 electrons on that side, or you can write plus 2 electrons on that side. Regardless, it's the same thing, okay? Now, for reduction, we know that MnO4 minus, we can write that on one side, and we can write Mn2 plus on the other side, okay? Again, charge has gone from plus 7 to plus 2, so that means that 5 electrons has been added, okay? So write plus 5 electrons. That's basically how to write the half equation for these. And if you want to how do I say this? If you want to combine these, you simply add these two, but you make these electrons the same value, okay? What do we mean by this? You can multiply this equation by 5, and you can multiply this equation by 2, so you get 5 SO, I need to write that, 5 SO2 to give you 5 SO4 2 minus plus 10 electrons, and on this one will be 2 MnO4 minus plus 10 electrons to give you 2 Mn2 plus. Combine these two, the electrons will cancel out, and you'll be given, you'll get your exact answer, okay? So yeah, that's how you do that. So we can just take that. In our next video, we'll look at 8b, the elements of groups 1 and group 2, which are, every video will have an individual portion of this specification in order to move very fast. Again, chemistry is very vast. The specification is not like the physics one. It's many pages of specification only. So yeah, we're trying to go a bit faster.